Okay, this next problem we're going to look at is deriving a mu series from an old series, an old Taylor series. So we're going to have to be within the radius of convergence. We're going to talk about that. And this one's going to be special because we're going to do some integration. It's a little bit different than the last one we did. So the first thing I'm going to notice, we start with this fact right here, right? So I'm going to notice I have d by du of arctangent of u is equal to 1 over 1 plus u squared. Now the function I really want is arctangent of x over 2 cubed, so let's see what that looks like. Instead of u, I'm going to use x, of course, because now my function is a function of x. And I have x over 2 cubed. So this is going to be, well, I'm going to have d by dx of x over 2 cubed on top, of course. And on bottom, I'm going to have 1 over x plus 2 cubed. But I'm going to have all of that squared, right? Because I have this whole argument squared. Okay, so what does that equal to? Well, be careful here. I made this mistake when I was setting up this problem. I have 2 cubed. So I have 1 over 2 cubed. This is the comment. This is a constant. And then I have d by dx x cubed. So that's 3 times x squared over 1 plus, well, now I have this whole thing to the 6th, right? So x to the 6th over 2 to the 6th. Or I can write this as 1 over 8, because that's 2 cubed. 2 times 2 is 4, times 2 is 8. Sorry, instead of 1, let's write it as 3, because I have this as well. So I have 3 over 8, and then I have x squared over 1 plus x to the 6th over 2 to the 6th. Okay, so, well, what do I know? I know the series for something that looks like 1 over 1 plus something else. So I'm going to write this as 3x squared over 8, and I'm going to look at this term on its own. I'm going to write as 1 plus x over 2 to the 6th. Well, and then I'm going to compare. I know, so if you don't know this, I would recommend writing it down. I know 1 over 1 minus x is equal to 1 over 1 minus negative x. And I know this series is k equals 0 to infinity, and I have my argument to the k factorial. Sorry, this is 1 plus. Sorry, 1 minus x to the k. And I'm going to write this as k equals 0 to infinity minus 1 to the k, x to the k. So I know this is true. So I have the similar thing here, but now instead of 1 plus x, I have x over 2 to the 6th. So if this is my function up here, I have, let's look on the next page, I have d by dx of arctan of x over 2 square or cubed is equal to, well, I had, what did I have outside? I had 3x squared over 8, 3x squared over 8, 1 over 1 plus, now I have minus x squared, or sorry, 1 minus negative x to the 6th over 2 to the 6th. So be careful. You always have to do this because we want it always to be something that's like, we want 1 minus something. In particular, we want 1 over 1 minus something. Okay, so what we have is 3x squared over 8, and now we have the 1 minus something that we want, and that's minus x to the 6th over 2 to the 6. Ooh, all to the k power, right? So then we have 3x squared over 8. K equals 0 to infinity. I'm going to bring out my minus 1 to the k, and I'm going to write this as x over 2 to the 6th, all to the k power. Or, if we're going to be really succinct about it, we can write this as k equals 0 to infinity, minus 1 to the k, and we have x over 2 to the 6k, right? Now, for Taylor series, we always want everything inside the series. So we're going to write this as k equals 0 to infinity. We have 3/8 minus 1 to the k. And then we have x. Well, we have x to the 6k. Well, we have plus 2 from this guy, right? So we have x to the 6k plus 2 over 2 to the 6k. Okay, so, but be careful. This isn't our answer yet, right? Because this is d by dx of our answer. So as long as we're within the radius of convergence, which is important, as long as we're within the radius of convergence, then we can integrate and get our Taylor series. Okay, so for the radius of convergence, you always look at the stuff with the k powers. So look at stuff with k power, because the other stuff doesn't matter. Now what we find is that we need 6 absolute value of 6 over, or sorry, x to the 6k absolute value of x over 2 to the 6k, or just to the 6, right? Because the k we get rid of. It just have to be less than 1, which is true only if absolute value of x over 2 is less than 1. So we need absolute value of x is less than 2. Okay, so that's our radius of convergence right here. Okay, so if we're within that radius of convergence, then, well, we know that integral of d by dx of arctan of x over 2 cubed dx, well, we know this is just equal to arctan of x over 2 cubed by the fundamental theorem of calculus, but we can also integrate term by term of our Taylor series. So we're integrating our series. So that's, well, we're going to integrate the series, k equals 0. I'm going to put a big bracket around this so we know what we're integrating. K equals 0 to infinity, and we have this stuff. So we have 3/8 minus 1 to the k, 6 to the k plus 2, x to the 6k plus 2 over 2x to the 6k. Over 2 to the 6k. So oops, let's put this in the same color. And then we have all dx. Right, this is just our series. We're integrating this. We integrated the arctan, so we have to integrate the series as well. Now all the stuff that doesn't depend on k I'm going to take out. Or also doesn't depend on x I'm going to take out. So I'm going to write this as integral, or because we're within our radius of convergence, we could bring the integral inside, right? That's the important thing. So we can write this as k equals 0 to infinity, and all the stuff that doesn't depend on x I'm going to take out. So I have 3 over 8 minus 1 to the k times 1 over 2 to the 6k, right? This doesn't depend on x. And then we have this integral, which is just x to the 6k plus 2 dx. And all this stuff is being summed if we're within the radius of convergence. So we have k equals 0 to infinity. We have 3 over 8 times 2 to the 6k times minus 1 to the k. And we integrate this thing, we just get x to the 6k plus 3 over 6k plus 3. Right, so that's just integrating that. And this is our answer. This is a fine answer. And the reason you can check if it's a fine answer is this is equal to k equals 0 to infinity ak x to the 6k plus 3. So as long as you can always write it as something ak times some power of x, you're fine. Ak is everything here, right? That's all ak. Okay, so that's your answer. And now we're done.